Hello everyone, I am Nur Sabah Khan from Group 15 and I have with me in this group Bilal Mufti, Hira Anis, James Matthew Hamilton and Shakir Shakur. The topic of our project is handling the curse of dimensionality through random lasso regression. In real-world scenarios, we frequently encounter datasets with a lot more features than samples, such that the ratio of features to data points is of the order of 500, especially in the field of bioinformatics and genomics. In such situations, the traditional regression techniques fail to produce beneficial results, and the accuracy keeps on decreasing as this ratio increases. This shortcoming of regression analysis leads to research constraints, and this pretty much makes up our problem statement. When all the customary regression techniques fail, then lasso regression comes into the picture. Lasso regression handles this issue with dimensionality reduction by reducing many of the coefficients to zero based on some features being more significant than others. Having said that, lasso regression has its fair share of limitations, hence creating a need to come up with improvised version of lasso regression, which we will call here random lasso. Random lasso brings in the notion of bootstrapping, where it fragments the dataset into several subsamples, imposing features equal to the number of data points, and runs lasso on each sample individually, in contrast with pure lasso that applies the algorithm on the whole dataset. Hence, the essence of our project will be the implementation of random lasso regression. We will start the project by gathering datasets, most expectedly from the field of genomics and bioinformatics, because it satisfies our requirements of features greater than samples. In the next step, we will pre-process our dataset. For that, we will use PCA as part of our unsupervised learning model to help us achieve an overall image of the sample clusters. This is the part where we pre-process and visualize the dataset for any anomaly or redundancy in our sample datasets. After that, we will split our process dataset into training and testing data. And then, based on our training dataset, we will train the model on random lasso algorithm that will make up our supervised learning bit of the project. Now, how do we know if our model is doing good, bad, or average? We certainly need some criteria for that. And therefore, we will then evaluate our model based on some goodness of fit criteria like RMSE, which is root mean square error, F1 score, or others. If we are satisfied with the performance of our model based on these parameters, then we will move on with deploying our model and bringing in novel flavors of random lasso to further optimize the performance of this unique algorithm. These modifications are not limited to, but might include changing number of bootstraps, number of sample features, etc. We will then use these findings to summarize our analysis in a report where we will discuss these results in detail. We are very excited to get started with the project and present something awesome to you. Thank you.